hard. Okay, so light is registered in the retina when photons hit molecules of the pigment R and change the molecule shape. Okay, so like our retina recognizes light when photons hit molecules and change the molecule shape. Okay, cool. Even when they have not been struck by photons of light, our molecules sometimes change shape because of normal molecular motion, thereby introducing air into the visual system. Oh, that makes sense, right? So like we have light when this happens, but sometimes like there's like other things that happen that cause this. The amount of this molecular motion is directly proportional to the temperature of the retina. Okay, so the amount of this molecular motion, which is referring to the normal molecular motion. Okay. So which of the following is most strongly supported by the information above? All right, go ahead and start with A and tell me if you like it, leave it, or hate it. And I'm already thinking, okay, so I should tell you what I'm thinking here on this last sentence. I'm thinking that the regular, like just the, like our molecules sometimes can change shape because of normal molecular motion. And then if the amount of this molecular motion is directly proportional to the temperature of the retina, I'm thinking that whatever's normal, like even like at the normal temperature, there can be like some type of air.
Okay.
Is kind of where my thought process is going. I'm like, there's some type of relationship between regular motion. This thing can happen because of normal molecular motion.
And the temperature.
And the temperature is directly proportional, or the molecular motion is directly proportional to the temperature of the retina. And so I'm thinking like, okay, so somehow those three like can interact with each other.
Okay.
All right, so let's go ahead and start with A.
All right. The temperature of an animal's retina depends on the amount of light the retina is absorbing. Depends. The temperature depends on the amount of light. I don't think it depends.
No, I don't think light impacts the amount of light. Like, no, not at all.
It just gives us a little like tidbit of what light does when it's registered.
Like it's like how we typically, but we're talking about airs and R's, and this is saying like the temperature of our eye does not depend on if light comes in or not.
Mm-hmm.
Excellent.
The visual systems of animals whose body temperature matches that of their surroundings, so proportional, are more error prone in hot surroundings than in cold ones. Okay. Their body temp matches that of their surroundings, so proportional are more error prone. Thereby introducing error into the visual system, and the amount of this normal molecular motion is directly proportional to the more error prone, maybe.
Okay.
I'm trying to say that
As one goes up, so if the molecular
yeah
goes up, the temperature goes up.
goes up with it. Yeah. So they're saying they're more error prone in hot surroundings. So the temperature goes up, then the normal
molecular motion goes up.
Yeah, maybe. Okay. As the temperature of the retina rises, our molecules react more slowly to being struck by photons. I don't know about more slowly.
I don't know what we say we react, like the temperature doesn't impact how we react to light being registered or the R molecules being struck by photons. Like that's just how light is normally happens.
Yeah, so I don't think it's C. Our molecules are more sensitive to photons in animals. More sensitive to photons. Okay. In animals whose retinas have large surface areas than in animals whose retinas have small surface area. It's not about the space.
Excellent.
No. Molecules of R are the only pigment molecules that occur naturally in the retina. I have no idea.
Yeah, so I would have gotten to this one by process of elimination, but I don't like B at all, to be honest, because How do we know that? Because it says that sometimes change shape because of normal molecular motion, thereby introducing the visuals, the air in the visual system. The amount of the molecular motion is direct. They're assuming that the more molecular motion, I feel like it doesn't tell
Like
us.
the more error or the more,
Yeah, the more air.
that's what I think it is too. And I think like they're attributing that also with proportional, um, it being proportional to temperature.
So I understand completely that when temperatures are lower, molecular motion is lower, and when temperatures are higher, molecular motion is higher. And I know that motion causes errors, but I don't like that necessarily, like it's like a hot faster motion that causes more.
Yeah, it's like a real, this is why I was like, this question's challenging, at least to me it was, because I couldn't really make sense of that either. But I had to just be like, now that I'm looking at it, I'm just like matching up what it says in the answer choice to like try to have it fit in the stimulus, and it makes sense to the stimulus.
Yeah, and this is probably why it's the most strongly supported and not a must be true.
Hmm.